So here's the same experiment with power supply going through to the inductor, 10 henries, half an amp, 37 ohms, going to a 12 volt light bulb. This time we've got a Verdia Go Direct voltmeter going to that nice switch and then back home. If we open up a Vernia graphical analysis, we go to a sample rate of about 100, will mean we get a better idea of what's happening. And so what we do is with the switch off, we crank it up to about 15 volts, and then we can click collect and then drop the knife switch, and we see the bulb slowly illuminate, and we see that lovely peak. It's a little bit interesting that it's not just a pure exponential graph. It kind of goes up and then down, and we were wondering if that's got something to do with the variable resistance, or how resistance changes as more current goes through. And so we can try that again. Remember that we don't turn the switch off because we've got that large back EMF which may damage the voltmeter, so we just dial down the power supply, disconnect the switch. We can connect this back up. Maybe we'll even go above 15 this time. We can go above that kind of 12 volts because of the resistance of the inductor. And then we can hit collect again, and if we drop the switch, we can see it takes some time to build up. And if we go to a lower voltage, so something like 8 volts or 10 volts, we'll get the same kind of picture. So collect, but it'll take a bit longer for that bulb to go. And so you can ask people why that is, and then you can do allographs, and then you can ask people why we can't do the opposite. If you disconnect the voltmeter, and if we're only running at 10 volts or so, the back EMF shouldn't be too drastic. And so, sorry, with the switch off, running at 10 volts, you can switch it on, and you can see the bulb take some time to glow. So it is glowing, and then if we turn it off, we'll see a bit of a spark there. It's actually not too dramatic. If we go 15 or so, I think that should be quite dramatic. Take some time, and then we see that's a fairly substantial spark.